Question 18 is looking for the heterozygous genotype. Yeah, heterozygous genotype. And yep, seems like it is related to the population genetic. And it is asking for the heterozygous. Yeah, so yep, it is related to the frequency of the heterozygous. Okay, so to solve this type of question, we have to use the type 3 method. All right, so now let's look at the questions. Yeah, so based on what the question gave, so 36% of 400 mice were found to resistant to a poison. Okay, and the resistant is controlled by dominant. Resistant is dominant. Okay, so that will means that those that is resistant to the poison, okay, would be 36%. Yeah, in the 400 mice population, 36% are resistant. And that would means that these 36% would be either homozygous dominant or heterozygous. Okay, so if let's say 36% are resistant, so what would be the non-resistant? So non-resistant would be 64%. Yeah, it would be 64% because very simple, 100%, right? In the 100%, 36% are resistant. So you take 100 minus 36. So non-resistant will be 64%. Yeah. So this 64% will be non-resistant, and non-resistant will means that they are homozygous recessive. Yeah, they are homozygous recessive. And once we have the homozygous recessive, then I think, yeah, we can find the P and Q. Why we need to find the P and Q? Because to find the heterozygous, you need to take 2 times P times Q. That's the 2PQ. So you need to find out what is P, what is Q. Okay, so over here, homozygous recessive R is actually the Q square. Yeah, they are the Q square, yeah, because they are homozygous recessive. Okay, so Q square is actually the frequency of the homozygous recessive individual. Okay, so that is why we can state Q square equals to 64%. You convert it into the frequency, it will be 0.64. Okay, so with that, Q equals to square root of 0.64, and we will get 0.8. So we know that Q is 0.8. Okay, so if you know the Q, then very easy. Given that, okay, P plus Q equals to 1. So P plus 0.8, because Q is 0.8, yeah, equals to 1. So P will be equals to 1 minus 0.8. And thus, we will know that P is 0.2. Okay, so once we know the P, once we know the Q, then now we can find the frequency of the, yeah, we can find the frequency of the heterozygous. Okay, so frequency of the heterozygous, because this is what we want to find, right? The question is asking for heterozygous genotype here. So frequency of the heterozygous would be equals to 2PQ. So 2 times P would be 0.2 and Q would be 0.8. So 2 times 0.2 times 0.8. Okay, so what we get, we will get 0.32. Yeah, we get 0.32. Okay, so that is the frequency. But obviously, the question is asking for number of mice to have the heterozygous genotype. They want the number, they don't want the frequency. Yeah, so that's why don't forget to find the number using the frequency here. Yeah, don't forget to find the number using the frequency, because I think a lot of students will make the careless mistake. They will end their answer here. Yeah, they end their calculation here, which will be wrong. Okay, because the question is asking for number. So that's why for number, you have to find a number. Okay, so the number of the individual with the heterozygous, yeah, it will be, you have to take the frequency, which is 0.32. You have to times the total population. So total population here is 400 mice. So you have to times the 400. You have to times the 400. So 0.32 times 400. Okay, so it will be, calculator, 1280. So that will mean that total 128 mice will be heterozygous. Okay, so that would be the final answer.